This video was made possible by StruSoft. Let's add some loads to our model. Use pointLoad.define to create a point load. You need to define the insertion point, force, as a vector. I am applying 100 kilonewtons of force in the negative x direction. Then you need to select what load case this load will be applied to. Then you need to decide whether you want to apply a linear force or a point moment. If you want, you can apply a comment to the load. This can help clarify what the exact load actually means, because there can be multiple loads in the load case. If we open FEM-design, we can see that the wind load that we just defined has been applied at the point that we selected. To add a line load, use lineLoad.define component. Linear loads require a curve that they are applied on. You can define the start force and the end force of the load. Here, my start force and end force are applied to different directions. I have again selected a load case. Constant load direction input defines whether the load will be constant along an action line. This will be explained in the next example. With the load projection input, you can select whether you want the intensity to be along the action line or perpendicular to the direction of the load. These come to play when you are working with sloped surfaces. If you select the along the action line option, the total load will be calculated by what is the component perpendicular to the beam. If you select perpendicular to direction of load, the total load will be scaled so that the perpendicular component is equal to the force value you have defined. In the FEM model, our line load looks like this. The starting force has been defined in the negative z direction, and the end force has been defined to the positive z direction. You can also select between force and moment or add comments to the load. Now let's look a bit deeper to the constant load direction input. Here I have an arc. So I have created a vector that is pointing from the middle point of the line in 45 degrees angle towards the center of the arc. When the input is set to true, the direction will be constant along the action line. When we open the model, we see that the direction is consistent along the beam. If we toggle this to false, the load direction is going to vary along the action line, and the characteristic direction is the middle point of the line. When we open the model, we see that the characteristic direction is here, and the load keeps on pointing towards the inside. This might be useful if you are calculating pressures or arcs of any kind.